Hello there, everybody. It's Darshan Govender here. Welcome to Byte Fusion. So, I just want to first start by saying that I know that some of you, at least a few of you who do follow me, expected a bit more content. And over the last few years, I haven't been able to deliver on that. I do sincerely apologize for it. Going forward, I hope that I have, the self-trust within myself to keep making videos for you guys. And I think it's really good. It's really good to learn about programming, you know? So a lot of you are probably engineers who are looking at this course. Some of you might be coming from a different background and may find that you'll want to learn how to code. So the focus for this education is really important. Yeah. So with that being said, let's get into Python, and today we're going to be doing data types in Python. Okay, so we have VS Code open right now. The first thing we want to do is create a file. So we're going to click on this, and I'm going to call this file data types.ipynb. Okay, so we have a Jupyter notebook open. The next thing we need to do is to set the kernel. I think now VS Code is trying to detect our kernel. Okay, so VS Code has detected that we're using Python as our language. That's perfectly fine. So what you want to do is create a code block or code cell. Okay, so let's discuss data types. So as we know in the introduction video, Python is an interpreter language, and basically Python allows you to define data types at runtime. So you can take notes of 4 primary data types that we'll use in Python. The first kind of data type that you might be familiar with is called an integer. An integer. And to create an integer, all we've got to do is first name our variable. Before we actually name our variable, I want to discuss naming conventions with you for variables. So to name a variable, you basically so maybe you might have a variable for mark, so you'll call the variable mark. So variables can be named with underscores, such as student underscore mark. You can also name variables using camel case, so student capital letter on the second letter and preceding mark. So here's 2 ways that you might want to consider when naming variables. Now, an important thing to note about naming conventions is that you don't want to have a variable that's too ambiguous. So instead of using the student mark or the student mark naming convention, you use something like X instead to show that that's a specific mark. That might be a bit difficult for another programmer or maybe your team who's collaborating with you to read your code. They might not be able to understand exactly what that variable is used for. So an important thing is to be descriptive whenever you're naming variables. So I'm going to comment these 2 names. The first kind of data type that we'll look at is called an integer data type. Integer data types allow you to store whole numbers. Here's an example of an integer data type. Num is equal to 65. Here's another example of an integer data type. Num is equal to negative 50. So you can store both positive and negative whole numbers with integer data types. Another data type that we'll look at is called a string data type. A string data type basically allows you to store more than one character. For example, name is equal to Samuel. We can also have other characters besides letters in a string data type. For instance, we can have Sam hash 45. This is also regarded as a string. The next kind of data type we can have is called a float data type. It basically allows you to store real numbers, numbers that have decimals. For instance, amount equal to 45.55 is a good example of a float data type. The final primary data type is called a Boolean data type. Booleans basically allow you to store true and false values. An example of this would be is valid is equal to true. Notice that when we name a Boolean data type, we are basically using a prefix with an adjective. So is valid is actually one correct naming convention for Boolean. You can also have has completed equal to false as an example of a variable that contains a Boolean value. Okay, so I've actually had to make a change. I had to change my Python environment to 3.12. And the reason why is because 3.14 was not working properly. So we're actually back at 3.12. Remember, you can always set up your kernel. And I know you might need to go through a lot, but just get it sorted out and we can proceed. So let's run this, this entire code cell. You can see that everything works perfectly, right? One last thing I would like to mention is that there's a data type that's not part of these 4 primary data types, and that's actually a char data type. And I'm going to show you how to create that now. So char data types allow you to store a single character. If I give you an instance of this, we'll call the variable char, and we'll say it's equal to a. And if we run that, you'll see that it actually works. So one thing to note about char data types is that you have to use single quotations, whereas in strings, you have to use double quotations. So how do we know that every data type that we've put down on this entire file is actually the correct data type? Well, there's a way to check that. All you've got to do is type in type and specify your variable. So actually, let's do this in a new cell. Type. So we're going to do this 6 times at least. Okay. Right. So let's actually print this onto our console. So what we've done here is that we've used the print function to print our type of our variable to the console. And the very first variable has a class of int, the second has a class of string, the third has a class of float, the fourth has a class of int, and the fifth has a class of string. So isValid was set to true, was set to 0. And because of it being set to 0, it got changed to a integer data type. But if we remove this isValid is equal to 0 and run this again, we'll notice a change. Now it says Boolean. So what did we learn from this? isValid if you declare a variable and initialize it, and then decide to change it, it will update the variable. Okay, so now isValid is true. So if we actually print isValid, we'll notice that we'll get it as true. The next thing we're going to discuss is called typecasting. Typecasting basically allows you to convert data types. So let's look at an example of this. I'm going to say that x is equal to 34. And I'm going to actually make this a string. So right now, if we try to print the type of x, if we try to print the type of x, we should get a string. As you can see, we've actually got the string data type. But what if we don't want x to be a string? What if we want it to be an integer? Then we can say x, we can say x is equal to int x. Now you look that the class is actually an integer. This is the first print, and this is the second print. Typecasting only works if the value that you are using can be represented as the data type you're going to cast it to. So let's look at an instance where typecasting would not work. In this example, you'll see that we actually assigned the value AB to Y, and notice that when we tried to cast Y to an int, it gave us an error, and it says here, invalid literal for int with base 10 AB. So clearly, when we try to typecast something that isn't an integer to an integer, it will give an error. What if we try to do this with a decimal? Notice that it also gives us the same error. Now let's look at another example. In this example, we basically typecasted the decimal 56.8 to an integer. Notice that the decimal points or the decimal numbers that come after the points have been removed from the variable because now we converted it to an integer. What this basically means is that we've truncated the values that would make it a real number. If you try to do the opposite, if you try to recover the number 56.8, it would be unrecoverable now because it's been truncated. Another thing that I want to discuss is inputs in a value from the console to the variable in Python. So now we know how to output values and how to assign variables. But one other thing that we might need to do is to ask for user inputs. So to do that, all you've got to do is type your variable, and then you've got to say it's equal to input, and then you put your message that you want to be displayed to the user. So for instance, I've put your enter your name. Let's see what happens when we run the cell. As you can see, it says enter your name and press enter to confirm. So I'm going to type my name. Notice that when I typed my name and it printed it out to the console because I've said print X. Okay, everyone, we've covered data types in Python. I hope this video has given you a clear demonstration of how to use data types, how to input and output values. We've also learned typecasting in this, and we've looked at different scenarios of how to handle variables. So I look forward to the next video. Until next time, Byte Fusion out.